Welcome to This Explainer. Today, we're diving into something we basically all take for granted, column addition. But we aren't just here to do some math. We're actually unpacking the anatomy of a masterclass to discover exactly how top educators break down this absolutely monumental concept so a child actually understands it.
Okay, let's dive straight into this. Think about it for a second. Think about the massive jump a child has to make when transitioning from simple mental math or counting on their fingers to mastering a reliable, written method for huge numbers. It's literally a monumental shift. You can't just hand them a worksheet and cross your fingers. It requires absolute precision.
To see exactly how the pros do it, we're going to follow a highly structured lesson plan. We've got 5 steps: setting up for success, modeling the basics, introducing the carry, fostering independent work, and finally, the golden rules.
Right, let's kick things off with Section 1, setting up for success, laying the groundwork. So in this brisk 5-minute starter phase, the teacher introduces the main goal by throwing a big, intimidating example out there. Something like adding 246 and 178. Now what's really interesting here is that the absolute most crucial rule is established before a single drop of math actually happens. It's all about place value and alignment. You explicitly show that, hey, a 6 simply cannot sit underneath a 7 if they belong to entirely different columns. No way. It is strictly ones under ones, tens under tens, and hundreds under hundreds. If the kids don't nail this setup, well, the rest of the lesson just isn't going to work.
Moving right along to Phase 2, modeling the basics, no carrying yet.
We've got an 8-minute phase here, dedicated purely to building up that initial confidence. You deliberately start with a super simple no-carry problem, like 246 plus 123. Watch how the master teacher systematically works column by column. You literally point at the board and ask, what is 6 plus 3? Boom, it's 9. Then, and this is key, you physically move one column over to the left. 4 plus 2 is 6. Keep moving left to the hundreds. 2 plus 1 is 3. You end up with 369. You're visually and verbally demonstrating the exact physical path their eyes and pencils need to take.
And to really cement that path, you lean into the magic of repetition. You establish this core rhythmic mantra: ones, tens, hundreds, right to left. But you don't just say it yourself, you've got to get the pupils chanting it out loud right along with you. Doing this embeds the entire procedure deep into their working memory.
Okay, time to up the stakes. Here's Section 3, introducing the carry, escalating the difficulty.
Now we bring back that much harder calculation from our introduction, 246 plus 178. But wait, before solving it, we need to drop in some clear jargon. A lot of us just say carrying, right? Well, in math terminology, this is beautifully described as exchanging. And honestly, it hits the nail on the head. It perfectly captures what's physically happening. We are exchanging a newly formed 10 and sliding it right over into the tens column.
This part requires incredibly deliberate, slow pacing. Look at the ones column. When we add 6 and 8, we get 14. You have to explicitly point out to the class that, wait a minute, we only have one space in that ones column. Sure, writing down the 4 is the easy part, but you really have to explain that the 1 doesn't just pull a disappearing act. That 1 actually represents 110, so it absolutely has to move next door into the tens column.
So, after adding up the rest of the columns, being super careful to include that carried 1 obviously, you arrive at 424. But the teaching doesn't stop just because you found an answer. You've got to instill a vital habit: checking the final result. You pose the question to the room: does my answer make sense? Teach them to estimate. Look, 246 is roughly 250, and 178 is close to 180. 250 plus 180 is about 430. So yeah, 424 is a totally logical result. It's right in the ballpark.
To brilliantly illustrate how this scales, punch in a massive 4-digit problem for your second example: 3,478 plus 2,596. Following the exact same rules, carrying across multiple columns, you're going to get 6,074. The real magic here? You're showing them that absolutely nothing has changed. It's the exact same right-to-left method, and it scales seamlessly to a number of literally any size.
Now, this is where the masterclass really shines. Before letting them loose to work alone, you don't just hand out a worksheet and say good luck. No way. The students have to explicitly articulate the process back to you using these 6 precise steps. Line up the numbers, start with the ones, add the digits, carry or exchange, move to the next column, and continue until finished. The rule of thumb here: if they can verbalize it, they are ready to actually do it.
Which brings us right into Section 4, fostering independent work, the teacher's true role. For the next 10 to 12 minutes, it's go time. Pencils hit paper. But notice how the mathematical scaffolding shifts based on the pupil's level. For example, P4 students might focus purely on lining up 3-digit numbers, starting with 0 carries before slowly dipping their toes in. P5s are tackling 4-digit addition, focusing heavily on remembering to actually carry that extra 1. And then your P6s. They're facing complex, multi-carry calculations that completely cross over into the 10,000s.
While they're working, a master teacher doesn't just stand at the front of the room. And they definitely don't just look at a kid's paper and say, nope, that's wrong. Instead, you're roaming the room using Socratic questioning. You lean in and ask, hey, which column are you starting with? Or where exactly does that 4 go? Or what does that 1 represent? By asking these targeted questions, you are empowering the students to actually spot and fix their own mistakes.
To wrap up that independent work, introduce a quick 5-minute challenge phase. You bring a strong pupil, or just someone who totally nailed the method, up to the board to explain their thinking to the whole class. Why? Because being able to explain how you got an answer is just as crucial as getting the answer in the first place. It reinforces true, deep comprehension for the entire room.
And finally, we hit Section 5, the Golden Rules, the final plenary. In the last 2 minutes of the lesson plan, we're distilling the whole session down to the ultimate takeaways. Think of this as your fail-proof, screenshot-worthy mental checklist. 1. Line them up. 2. Start on the right. 3. Add the ones. 4. Carry if needed. 5. Move left. 6. Whatever you do, don't forget the carried number. 7. Keep going. And 8. Always check if your answer makes sense.
We'll conclude this explainer with the ultimate diagnostic question for any educator to ask themselves. Do your students really understand place value? And do they consistently work right to left? Because if the answer is yes, the actual addition part becomes remarkably easy. Honestly, it makes you wonder, if we can break down a complex math concept into such a beautifully simple, foolproof structure, what other impossible subjects could we completely conquer if we just taught them the right way? Thanks so much for joining me on this explainer, and I'll catch you next time.